Now I've covered a few various different forms of movement options in my tutorials. Simple things from locomotion to even more advanced things like being able to jetpack around or grapple onto objects within a level. But something that I haven't covered that just about any VR game basically has to have is teleporting. And a large reason for this is because while locomotion and grappling and movement systems like that are really nice to have, not everybody is capable of handling that kind of movement. Some people will only be able to move around through teleportation due to motion sickness or other factors like that. So in this tutorial, I'm going to show you how to set up some very simple teleportation mechanics that you can set up on any VR character, whether it be a pawn character or some other player class that you decide to use. But before we go ahead and jump into that, if you enjoy this video and want to see even more just like this one, be sure to hit the like and subscribe button down below. And with that, let's jump right into the video. All right, so before we go ahead and jump into creating our character, I want to talk a little bit about our setup that we have here, because there are a couple things that, while not necessary, I would highly suggest that you have if you want to follow along with this tutorial. So start out, before we look at what's going on here in the scene, I'm going to start by showing you this mesh that I actually imported. This is from the Unreal Engine 4 VR template. I was not able to find this or anything similar that would be acceptable in Unreal Engine 5, so I ended up importing this instead. So you can see this is the mesh that we're going to be using. This is going to be for our arc on our teleportation, so we can actually see where we're teleporting to. I would suggest having something small, something that kind of represents a cylinder, something similar to what you see here. You can see that we clearly have no faces on two of those sides there, but everywhere else we do have more of a cylinder shape. So I would suggest having something like this and having it somewhat small as well. We're going to be using this, since we'll be using this in order to attach it to a spline mesh component and actually show where our arc is. So you can use a completely different mesh as well. It doesn't have to be this shape, it doesn't have to be this size, it doesn't even have to be this one at all. You could use something completely different, but just keep in mind if you use something quite a bit larger, you may get undesirable results. So I would just suggest whatever you use something small. So that is the mesh we're going to be using. The other thing, looking here at our scene, you may be confused by our single cube here. So I'm going to go and press P here on my keyboard, and you can see we get a whole bunch of green here, except for around this cube. And this has to do with how we're going to set up our teleportation. Now, there are some scenarios, because of the way that teleporting works, where players may try to teleport to a spot that you don't necessarily want them to go to. Maybe you have several different islands and you only want them to be able to teleport to certain ones. Or maybe you have, maybe they're trying to teleport over a wall that they shouldn't be able to get over. This is going to be used in order to stop them from being able to teleport where they shouldn't. And this is all set up using a nav mesh, which is this volume right here. If I go and hit that rolled outliner, you can see it's a nav mesh bounds volume. And we're going to use this navigation data in order to determine if we can teleport to that spot. And if not, we're going to find the nearest possible spot that we could teleport to in order to find a place that we can teleport to. Or if there's no place at all we can teleport to, then that'll be a different scenario as well. So that's the reason for this setup here, why I have this cube here. I'll be showing you that I can't teleport on the cube, I can't teleport right next to the cube, but I should be able to teleport near it. So that's just going to be what that's for. So I'm going to go and press P there. And so that's our nav mesh bounds volume setup. So that's all our initial setup. That's how I have this scene set up right now. So we're going to go and now jump into developing our character. So I'm going to right click here and create a blueprints folder here. And I'm going to create a blueprint class. And you can use a pawn, you can use really any different class that you want to, that supports VR, of course, that will support your VR character, of course. I'm going to be using a character, and the reason for this is that this character is actually a fairly normal representation of why you may want to redesign teleporting. Our VR pawn by default already has teleporting built in, but it's not really great for locomotion movement or something like that. And that's why I do like using a character in a lot of scenarios. So this This is actually a very reasonable scenario. I will be showing you some steps that aren't necessary for a VR pawn just because we're using a character. It has a few additional components that you won't find on a pawn. And it's really only going to come down to our initial setup here. So if you want, you can certainly use a pawn. I'm just using a character for this example. All right, in our character here, let's go and get started by getting some of this set up. And I actually want to start with our capsule component and character movement. Again, if you're using a pawn, you won't need to follow these first couple of steps, so you can go and skip forward a little bit. But since I'm using a character, I do need to take a couple of additional steps for setting up our VR player. So, starting off with our capsule component, I'm going to set our capsule radius to 1 and our capsule half height to 1. And this is just to keep our player from being raised higher than they're supposed to be. If the half height's set way too high, then it'll actually increase the height of our player. So it's just a good first step there. The other thing is I'm also going to disable gravity on both our capsule component as well as our character movement. So I'm just going to look up gravity and set our gravity scale here to 0. This is just going to make sure we can't fall off the edge. Because this capsule component is actually at the center of our play space, then it's possible that we could teleport to a spot where a capsule component will actually fall off the edge, and this will just kind of stop us from falling off that edge. So a couple of additional steps that I would suggest taking. If you want to keep your character, your capsule component following around with your camera, I have actually developed a tutorial for that, and there will be a link somewhere up here in the corner if you want to go check that out, and you don't have to follow the gravity steps there. All right, a couple of additional components that we do need to set up here, and this is going to be for both the pawn and the character regardless of what you're using. We're going to need to attach a camera. This is going to be so we can actually see through our HMD, our head-mounted display, whatever VR headset you're using. And then I'm also going to add in 2 motion controllers. This first one's going to be called motion controller left, and I'm going to create a new one here, call this motion controller right. And make sure that these are attached to your root component. They're not attached to the camera, they're not attached to each other or anything like that, because again, that can affect tracking, and it can throw things off, things like that. Last couple of steps, I'm going to take our motion controller right, and I'm going to set our motion source to right. I'm also going to take both of these, and I am going to give a display device model. I just like setting up a custom model personally. You can use the default if you would like, and I'm going to use the Avive pre-controller mesh. So that's going to be my setup there. So with our main character all set up, now that we have all of our components set up and all of that, this should be the very basics that we need in order to get started here. So now we can jump into our event graph and developing our functions. Now, typically this is where I would start, is in the event graph. However, we actually have a couple functions that I think would just be better to develop beforehand. So we're going to get started with that. So I'm going to start with our main function here. And I'm just going to call this teleport arc. And this is going to handle, it'll handle most of our teleportation. So we're going to have a lot going on here. I'll be taking this as easy as possible, so that way it should hopefully all make sense. But this will definitely handle the biggest chunk of all of our teleportation. So just keep that in mind as we are going through here. So get started here. Let's go ahead and create 2 inputs here. So I'm going to make them both vectors. And the first one we're going to create is going to be called starting location. And I'll show you what both of these are in a second. The second one I'm going to create is also going to be a vector, and this one's going to be called forward vector. Now, what these are for is we are going to predict projectile path by trace channel. And what this does is, we can actually look at the description to it. It actually tells us what it does. It predicts the arc of a virtual projectile affected by gravity with collision checks along the arc. So this quite simply does most of what we're trying to do, or at the very least the basics of what we need to do. This will actually create an arc that we can use. So I'm going to go ahead and run that through as our first execution here. And our starting location is just going to go straight into starting position. And our forward vector is going to go into launch velocity, but I want to make one modification here. I want to multiply this value by some float, and I'm going to make this a local variable, and we'll call this forward force is what we'll call it. I think it's pretty, it's a pretty reasonable name for it. And I'm going to make this a float, and I'm going to bring this out, and we will feed that into our second multiplication there, and that's going to go into our launch velocity. What this will do is this will allow for us to trace out further so we can teleport further. So the greater this value is, the further out you'll be able to teleport to. Now, I usually like a decently large value for this, so I'm going to start with 500. This may be just a little bit too big, but I would definitely suggest somewhere around this value to start. And then let's see here. The other thing that we need to modify as well is this trace channel. So if we actually go back into our level here, we of course want to be able to teleport to places like our platform here. But if we go ahead and check here in our details, we actually have this set as a collision preset default. And by default, this collision preset is actually world static. So world dynamic is not what we want to trace for. We want to trace for world static there. And that is all that we need there for the start of our predict projectile path. Now, if you want, you can go a little bit further. You can debug this arc later on, be able to draw what it looks like at various points. It doesn't actually show the whole line. It actually more shows points along that arc, so you can get a general idea of where this arc is going, what it looks like, so on and so forth. So I'm just going to leave that as is. And now we're ready to move on to the next step here. So our next step is we're first going to start by creating an outpath position variable that we can use later on. So I'm going to promote this to a local variable, and I'm just going to call this paths. We'll be using this in order to actually draw out our arc along the path. But before we can actually draw our arc, we need to be able to remove any existing arc first. So the way we're going to do this is I'm going to create a new variable. This is going to be a public, not public variable. This is going to be a variable for the whole character, not a local variable specific to this function. I'm going to call this, we'll call this spline meshes. And let me go ahead and look up spline mesh component is what we're going to want here. So I'm going to make that an object reference. I'm going to promote this, or I'm going to change this to an array, not a single. And we can go and take this, and what we're going to do is for each of these spline meshes, we're going to destroy them just like that. And then as a little additional precaution, we're also going to take this spline meshes, I didn't mean to right click just yet, like that. I'm going to clear just like that. And that'll just make sure that we don't have any spline meshes stored in here. We don't have any invalid spline meshes or anything like that. So that is the start here. So what this does so far is this will get our arc. We'll get several different points along that arc so we can use that to draw our arc for our player to see. And then we're removing the original arc that supposedly is already there. If there's nothing there, then this is only going to try to clear the spline meshes and basically do nothing. So now that we've cleared the existing arc, assuming that there is one, of course, now we're ready to draw our new arc. So we're going to do this by first off creating a for loop here. And not a for each loop, that will be probably the first thing that comes up for you. We are going to be using a for loop, and I'll show you why in just 1 second. For this for loop, we're going to set the first index to 1. Our last index, I'm going to take our paths here, and I'm going to get the length of this array. So in case you don't know what this does, this length will basically just return how many different vectors we have in this array. So if we have 100 different points stored in paths here, it'll return 100. If we have 50, it'll return 50. If we only have 1, it'll return 1. The only thing that we will need to do is subtract this by 1. And the reason for this is we don't want, if we have 100, we only want to go up to 99, not 100. So that's just why I'm subtracting 1 from there. So that is our for loop. Now in our for loop, we're going to start by adding a spline mesh component, just like that. And you also can spawn an actor and spawn a spline mesh component actor, I think is what it's called. But if you choose to use add spline mesh component, one of the nice things about doing this is you can shorten some of your blueprint code here, because you won't need to set things like a static mesh material, anything like that. By adding on additional nodes here, we can just do it right over here in the details panel. So it's just a nice, simpler way of doing things. So here in our spline mesh component, starting off here in our details, I'm going to set this static mesh to our beam mesh that I had shown you at the beginning. So this is what our arc is going to look like. So whatever mesh you're using, whatever material you're using, that's what's going to be applied to each spline mesh in our arc, because it's going to be made up of multiple. The other thing that I would suggest doing, it's not a necessity, but you will definitely get some weird results, is I would suggest making sure manual attachment is set to true. I have gotten some weird results if you choose to leave it as false, where the arc will look correct, but it won't be in the correct position. It's typically too far to the left, too high above, or too far to the right. So it can just kind of do some weird things. So I would definitely suggest checking that. And once we have the spline mesh component set up, we need to first store it in our spline meshes here. And this is so we can, again, go back and clear this later on. So I'm going to take our spline meshes and I'm going to add this new spline mesh component to our array of spline meshes. And the last thing we need to do here is, the reason we actually are using a for loop and not a for each loop, is I'm going to take this and I want to set start and end. Now what this does is this allows for us to determine where the start point and the end point of this mesh is. And if you want, you can also set the start and end tangent. You might get an arc that looks a little bit different if you decide to add in start and end tangents. I won't be doing that in this tutorial, just to kind of save on time in this tutorial here. So I'm only going to be putting in the start and end position. So for our start and end position, this is where this for loop comes in. I'm going to get paths, and from this paths, I'm going to get a copy. I'm going to get two copies actually. So I'm going to get two copies here. One copy is going to be the current index that we are getting through our for loop. The other is going to be our index minus 1. And the reason for this is, and this is also why we're using a for loop, is if we start at our first index 1, then we can go back and grab the actual first point in our path and just kind of save ourselves on a little bit of time. You can also do this kind of in a reverse position by adding 1 onto this one instead, subtracting by 2 and setting our first index to 0. That's another option. But I personally just like this solution. I think it's a little bit easier. It's a little bit easier to work with. And then now looking at here, let me go and try and organize this a little bit. There, just like that. So for our previous path, the one subtracted by 1, that one's going to go into our starting position. Our ending position is going to be the current index, so the one that's not subtracted by 1 here. And I'm just going to move that forward just a little bit, just like that. So now that we've drawn our arc and we can see where we're teleporting to, now we need to actually figure out, first off, if we can teleport to that location, and if not, then what is the nearest point we can teleport to. So we're going to have to first come back here to the very beginning where we have this predict projectile path by trace channel. From here, we're going to be needing both the out last trace destination as well as the return value in order to actually determine if we can teleport to a spot, and also if it's a navigational point. And if not, then we'll find the nearest navigational point. So in order to do this, we're going to start by taking our return value, and I'm just going to run this through a branch. Let me go and pull this forward and create a reroute node here, just like that. Now this is going to run through the completed on our for loop, since this is going to run after we have drawn our new arc. So here in our branch, at this point, we're basically checking to see if we've actually hit something, if we've hit anything at all. It doesn't matter what. If it's world static and we've hit it, then that's the point that we've determined that we have actually hit a point. So if we haven't, because we're going to start off here with the false, if we haven't, we need to not teleport anywhere. So in order to set ourselves to not teleport anywhere, I'm going to create a variable here, and this is going to be a vector. I'm going to call this teleport location. And on false, we're going to set teleport location to our current actor location. Actor location. What this will do is it basically won't teleport us. If we've determined that there's nothing that we have hit, then we're just going to leave our position right where we're at. And that's all that this is going to do. Now, if we have hit something, then let's first come back here to last trace destination. I'm going to drag this down real quick, and we are going to project, let me see, I believe it's project point. Project point to navigation, just like this. Let me go ahead and reroute this a little bit and move this forward. What this will do is this will actually take our point, and if it's already on a point that we've determined is that is a navigational point as determined by the nav mesh, then it's just going to leave that point there. If we're not at a point that we can actually navigate to, then it's going to find the nearest point that it can. Now, it won't always find a point, so, and that's why we have this return value here. So if we haven't found anything, we're again going to run this through branch. And again, if we haven't found anything, then we're not even going to try and teleport anywhere. We're just going to copy this get actor location, set teleport location, and that's going to go through the false. Now, if we have found something, then we actually need to teleport to a location. So we're actually going to need to do this in a couple steps. So let me go ahead and start by getting our set teleport location here. And I want to do this a little bit differently, because the way that our character works is our capsule component actually stands as the center point of our teleportation, of where our play space is. So if we were to just pass through our actor or if we were just to pass through this projected location, what it would actually do is it would teleport our capsule component to that point, which means that we might be a little bit offset. So we're actually going to use our camera in order to offset that location, and so our player themselves is actually what teleports to that location. So we're going to do this by taking our camera, and I'm going to get the relative location from our camera. And I'm going to split both of these real quick. Now, our Z, we're just going to pass through from our project point to navigation. Ooh, I did not mean to do that. Let me go and delete that, bring this down, and we need to split that struct pin. Let me actually move this around a little bit so that way it looks a little bit neater. A little something like that. All right. So our teleport location Z is going to just straight up take our project point to navigation. It's just going to take it. Our X and our Y, we're going to each subtract by the camera's X and Y, and then it's going to go into our teleport location X and our teleport location Y. So let me go ahead, get a couple of subtractions going on here, just like that. And I'm also going to reroute this just to try and keep it a little bit neater, just like that. And that will actually teleport our player themselves to this location rather than the capsule component, the center of our play space. So that way, if our player is not in the center of their play space, it'll teleport. And that is our whole teleport arc. So now we have found a place to teleport to. We are drawing our arc, and as well as removing the previous arc, if there is any. And that's all that we need to do there. Now, before we jump into our event graph, I want to create one more function. And I'm just going to call this clear arc. What this is going to do is once we've actually teleported to a spot, our arc is going to remain. So what we want to do is I'm going to get our spline meshes. And for each one, I'm going to go ahead and destroy that component. Just like that. And then I'm going to clear our spline meshes as well. Now, you may also recall that this is actually included in the teleport arc as well, right here, right after we predict our projectile path to trace channel and we have stored our path. This is basically the exact same thing as we're doing in clear arc. We're doing the exact same thing. We just need to do it. We just need to add it into an additional function, only because if we don't do this, then we'll have a arc that just kind of stays there until we go to teleport again. So that's the only reason I added in that clear arc there. So I'm going to go and close all those. And now we can get started here in our event graph. So here in our event graph, let's go ahead. I'm going to start by removing our begin play and begin overlap because we're not going to be using either of those. We will be using the tick though. That's going to be used for the main chunk of everything that we're doing here. And we need a couple of inputs that we can use to actually teleport. So for me, I'm going to choose to use the trigger. So I'm going to grab trigger left as well as trigger right. Now, in case you don't find trigger left or trigger right, just go into your project settings under input and then under action mappings. This is where I'm getting those names from, trigger left and trigger right. And if I go and hit those drop downs, you can see it's tied to trigger, their respective triggers for the Oculus Touch Controller, Valve Index, Mixed Reality, or Vive. So that's where I'm getting that trigger left and trigger right in case you don't see it and you're a little confused as to how I'm getting that. So here, once we have our trigger left and trigger right, let's go and create two variables because we're going to need two variables to be able to tell if our trigger is being held. So I'm going to create one called trigger left held, and that's going to be a Boolean. Second one called trigger right held, and that's also going to be a Boolean. And what we're going to do is on press for our trigger left held, we're going to set trigger left held to true. On released, we're going to set this to false. And I'm also going to add in one additional step. This additional step is I'm going to take trigger right held and set to false. This is just going to prevent us from being able to teleport with both hands, since that can cause some weird interaction sometimes. So I just personally like to make sure that we're only teleporting with one hand at a time. You don't have to do this, but this is how I'm going to be setting up my, this is going to also impact how I'm setting up the event tick, so just keep that in mind as well. And I'm going to do the same thing here for trigger right. I'm going to set trigger right held to true. On pressed, on released, I'm going to set it to false. And again, I'm going to go and grab our trigger left held, make sure that's set to false as well. Now the final step that we have here is actually using our teleportation functions that we created, as well as tying in our triggers to actually trigger those. So in order to do this, I'm going to first get a, not equal, I was looking for sequence, sequence, there we go, just like that. And we're going to use this for each of our hands. So we're going to start up here with our left hand. If our trigger left is held, we're going to run that through a branch here, just like this, on then 0. If our trigger left held is true, then that means that our trigger is being held. So we're simply going to run teleport arc. And you'll recall that we did ask for two inputs, starting location and forward vector. And this just to make it a little bit easier so we can use either hand. So for our starting location forward vector, since we're using our left hand, I'm going to grab our motion control left, get the world location. That's going to go into our starting location. And then I'm going to get forward vector, and that's going to go into our forward vector, just like that. Now, on false, let me actually move this forward a little bit. I didn't think this part through. On false, we're going to feed this through a do once. Now on this do once, we want to start it off as closed. This will just make sure that we can't teleport right off the start. And then we're also going to want to take our teleport arc. Once we've finished with our teleport arc, we're going to reset this, because this means that we've now held our hand, and we should at the release be available to teleport again after this is all done. So here on our do once we have completed this, we're first going to check to see if our trigger right is held. And the reason for this is if it is, then that means that we basically just swapped hands. We've basically gone from holding on our left hand to holding on our right hand. We've just swapped. So we want to make sure that we didn't just swap and we're not just about to do some teleportation and then the player tried canceling it out or something like that. So that's why we're doing this. So we're going to be running this through false. On false, we're going to set actor location, and that's on false. And our new location is going to be from our teleport location, which you'll remember we set in our teleport arc. And then the final step here is we're going to take clear arc, and we're just going to run that at the end. So that way we can make sure that our arc is all cleared up. So rather than just writing all this again, I'm just going to copy all of this, bring it down, and we're just going to modify some of these inputs for our right hand. So let me go and move this around a little bit. Just like that. So this gets changed to trigger right held. Let me go and feed that in. Over here, this gets changed to motion controller right. Go and grab that. And right here, this needs to be changed to trigger left held as well. Just like that. And that is our whole teleportation character setup. So I'm going to compile and save all that, close out. And then here in our scene, I'm going to drop our teleporting character right there in the center. And in details, I'm going to make sure that this is auto possessing player 0 and auto receiving input from player 0. And that is our whole setup. So I'm going to go and jump into VR and we can give this a test run. All right, so now we are in the level. You can see we don't really have much going on around us since a lot of this was to do with the character. We do have our cube over there, so let's go and start by just trying to hit trigger here. And you can see once I hit that, then we have our arc come out. You can see it's not a perfectly smooth arc, but it is definitely, it's pretty decent. It does get the job done. So let me see if I can jump over to that little spot there. And you can see I did jump right here. I am in line with that cube, and so I can try and teleport into it, and you can see it just basically teleports me as close as possible. It won't actually let me teleport into it. I might be able, yeah, I can teleport to like other sides of it since there is navigation all around the cube, but it won't actually let me teleport into it, which is a big thing. I can also try, let's see, if I try teleporting off the side, you can see our arc does go quite a good ways down there. So if I try and like teleport off the side, it won't let me do that either. It does completely confine me to any place that's navigational, that actually falls within the nav mesh data. So you can see it does a pretty good job here. Doesn't seem to let me actually teleport anywhere if I just start in the cube. Yeah, it doesn't look like it. So, but that should kind of give you a pretty nice general idea. The only thing I would say is that this is, of course, a little bit snappy. But of course, that can be kind of improved upon if you want to add like a fade in, fade out on each teleport or something like that. It would all be pretty simple, just adding all that in there at the tick. But yeah, this is our teleportation, and also I probably should have shown too. Works with the left hand too. So left, and then if I go and switch to right hand, you can see left hand does nothing, and same if I go other way, just like that. So everything works, and it all works pretty well. So there is our teleportation character. And with that, that's how we set up some very simple teleportation mechanics that can work on a character, pawn, or any other player class that you may decide to use. I hope you enjoyed this tutorial. If you did, be sure to hit the like and subscribe button down below. And also I'll give a quick shout out to my Patreon supporters who you should see over here on the right hand side. And with that, I'll see you in the next reality.